Welcome, everyone. Today, we are tackling one of the most demanding tasks in academia and professional research, the literature review. We will explore how to use Claude to systematically process, organize, and synthesize academic papers while strictly maintaining academic integrity. Let's get started. Let's begin by defining what AI-assisted academic research actually looks like. It is not about having an AI write your paper. That is a fundamental violation of academic integrity. Instead, it is about using Claude as a highly capable analytical partner. In today's academic landscape, the challenge is no longer finding information, it's making sense of the overwhelming volume of it. Claude's massive context window allows you to upload entire libraries of academic papers and systematically query them. When you do this correctly, Claude acts as a force multiplier for your own cognitive abilities. It can instantly highlight where two authors agree, where their methodologies diverge, and where the gaps in the current literature exist. By shifting your mindset from Claude as a writer to Claude as a research librarian, you unlock an incredibly powerful workflow that enhances your original research rather than replacing it. Take a look at this flowchart, which illustrates the proper relationship between you and the AI. It all starts on the left with the human researcher. You guide the Claude AI partner, which in turn processes the vast academic literature. The output of that processing isn't a final paper, it's a systematic analysis. You then take that analysis, apply your own domain expertise and critical thinking, and use it to inform your original validated research. The human is always in the driver's seat. To use Claude effectively, we must abandon random prompting and adopt a systematic research framework. This is a rigorous, four-phase methodology. Phase 1 is research design, where you and Claude define your core questions. Phase 2 is information gathering, where you upload your validated sources. Phase 3 is analysis and synthesis, where Claude helps you identify patterns. Finally, Phase 4 is documentation, where you map out your conclusions. Why must we be so structured? Because vague questions yield vague, and sometimes hallucinated, answers. If you just ask Claude to summarize this paper, you get a generic overview. But if you apply an outcome-first approach, telling Claude exactly what variables, sample sizes, or theoretical frameworks you are tracking, you transform Claude into a precision extraction tool. Structure is the ultimate defense against AI hallucinations. This flowchart maps out the 4 phases of the systematic research framework. Notice how Phase 3, analysis and synthesis, is highlighted. This is where Claude's true power lies in a literature review. You aren't just passing through these steps randomly, it is a linear, deliberate progression. You must complete the design and gathering phases using your own academic judgment before you invite Claude to help synthesize the data. Let's dive into the mechanics of handling the actual documents. In academia, the PDF is the standard currency. Historically, AI models struggled with PDFs because they would just scrape the raw text, destroying the formatting and completely ignoring charts. Modern Claude models change this entirely. You can securely upload these PDFs directly into your workspace. But the real magic is in the deep dive. Claude's advanced PDF processing actually converts pages into images behind the scenes, allowing it to perform true visual understanding. When you upload a medical trial or a physics paper, Claude isn't just reading the abstract, it can actively interpret the complex data visualizations, scatter plots, and data tables embedded within the document. You can literally ask Claude, what is the trend shown in Figure 3 on page 12, and it will analyze the visual data for you. Here we see the dual pathway processing that Claude utilizes for PDFs. When you upload an academic PDF, it enters the processing engine. It doesn't just go down the standard text extraction route. It simultaneously takes the advanced route, performing visual chart and graph analysis. These two streams of data combine at the bottom, resulting in a comprehensive document understanding that respects both the prose and the data visualizations. Now we reach the core of the literature review, summarization and synthesis. Anyone can write an annotated bibliography, but a true literature review requires you to synthesize a cohesive narrative out of disparate sources. This means finding the hidden threads. You must prompt Claude to identify areas of consensus, highlight glaring contradictions, and pinpoint gaps in the existing research. How do we do this practically? We use a research synthesis matrix. You upload your papers and prompt Claude to create a table mapping each paper against specific variables like methodology, sample size, limitations, and core findings. As a senior researcher, you also need to optimize this process. By utilizing Claude's prompt caching feature, you can load a massive stack of papers into the system once and query them iteratively for hours. This drastically reduces your token costs and gives you lightning-fast responses while you interrogate the literature. This diagram illustrates the synthesis engine at work. We feed multiple, distinct papers into the central Claude processing node. Instead of outputting isolated summaries, the engine is prompted to look horizontally across the documents. It branches out to identify where the authors agree, highlight where their data contradicts, and map out the research gaps that none of them addressed. This is how you build a literature review narrative. We must address the most critical risk in AI-assisted research: hallucinations. AI models are incredibly articulate, which means when they guess, they sound completely convincing. They can invent plausible-sounding academic papers or methodologies that never existed. Because academic integrity demands absolute factual accuracy, blindly trusting AI output is professional negligence. How do we protect ourselves? We verify everything. First, apply traditional librarian standards like the CRAP test to your sources. Second, demand verbatim quotes in your prompts. Tell Claude, do not summarize the methodology, quote it exactly as written in the text. For a deep dive defense, implement chain of thought verification. Force Claude to explain its logical steps and cite exact page numbers before it gives you the final answer. This forces the model to ground its reasoning in the text, severely limiting its ability to hallucinate. Look at this strict verification workflow. When Claude generates a claim, you hit a decision gate. Does it require verification? In academia, the answer is always yes. You then manually cross-reference the claim against the original PDF. Is the claim truly grounded in the text? If yes, it safely enters your literature review. If no, it drops into the red discard bin. Trust, but rigorously verify. Organizing citations effectively is what separates a messy draft from a rigorous academic document. When Claude is synthesizing 5 different papers, it is incredibly easy to lose track of which author made which claim. Proper attribution is the bedrock of academic honesty. To maintain this, you must engineer your prompts to enforce strict citation rules. Command Claude, for every single claim made in this summary, append a citation linking it to the specific uploaded document and page number. If it cannot cite it, it cannot write it. For those of you building custom tools or using the Claude API, there is an incredible native citations feature. When enabled, Claude doesn't just guess where the text came from, it parses the documents into chunks and returns the exact character indices and the verbatim quoted text alongside its response. This guarantees that the attribution is flawlessly mapped to your source material. This sequence diagram shows the underlying mechanics of proper citation generation. The user asks for a synthesis with citations. Claude queries the source documents, scanning the text. Crucially, the source documents return the exact text along with its precise location index. Claude then synthesizes the thought and attaches the mathematically precise citation back to the user. It leaves no room for ambiguity. Let's tie all these concepts together into a real-world use case. Imagine a graduate student tasked with reviewing 15 dense papers on the economic impacts of climate change. The challenge is that these papers seem to present completely contradictory economic models. Doing this manually would take weeks of tedious reading and highlighting. Instead, the student implements our pipeline. First, they upload the PDFs. Second, they deploy a research synthesis matrix prompt. They ask Claude to extract the exact methodologies, key findings, and limitations into a structured table, complete with strict citations. The outcome is phenomenal. Claude produces a structured map of the literature that immediately reveals why the papers contradict. For example, it highlights that the authors used completely different economic discount rates. The AI did the tedious data extraction, freeing the human student to perform the brilliant, high-level critical analysis. Follow the pipeline in this diagram. We start with 15 raw PDFs uploaded into the workspace. We use targeted prompts to split the extraction into 3 streams: methodologies, key findings, and limitations. These streams are combined to generate a clean, structured synthesis matrix. The final and most important step is that this matrix is handed off to the human researcher for critical analysis and the actual writing of the paper. As we conclude, we must talk about the non-negotiables of academic integrity. Using AI ethically means operating within strict institutional boundaries. You must never use Claude to write your final paper or to bypass the actual learning process. AI is a tool for capability amplification, not a substitute for human intellect. To maintain your integrity, apply the 80-20 rule. Use Claude for 80% of the heavy lifting: the data extraction, the formatting, the summarization. But reserve the crucial 20%, the final judgment, the critical analysis, and the actual pros entirely for yourself. Always verify your specific university's policies on AI use and disclose your use of these tools when required. By maintaining your critical edge, you ensure that your research remains genuinely yours. Thank you for joining this deep dive. Please like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram illustrates the boundary of academic integrity. When using AI assistance, you must perform an integrity check. If you are using it for ideation, organization, and extraction, that is acceptable use leading to human synthesis. If you cross the line into direct text generation, you commit an academic violation, opening yourself up to severe plagiarism risks. Stay on the green path, use Claude to empower your thinking, and always do your own writing.